Welcome to Spring LIB.
Here we have this little contraption of 3 pulleys and 3 hanging masses or blocks. And so we have two cables. So this cable comes over these pulleys and attaches to the center of this pulley, and then there's another cable rolling over that pulley. So we need to do a little bit of kinematics analysis here, but that's not too difficult. We know that, let's see here, we're going to call it positive down, and so I have, the force is acting on all of our blocks and on here, so we'll go through that. So let's say we're told that this block weighs 10 kilograms and these each weigh 5. We know that this block here drops 3 meters. I think that should be a plus. Yeah, let's see here. Yeah, that should be a plus because we have because I said positive was down, I think. Let me look up the problem, make sure that it said it could raise up. Yeah, it could rise up, but so let's take a look and see what the problem actually says. I can find the problem. Let's see here, number 28. Let's see here. 28 moves through meter. Okay, it just says it moves through 3 meters in 2 seconds. So it doesn't say. Well, we got a load. I forgot about this extra load acting. On it. So we're assuming that it's probably going to move down. So I'm going to say it's plus 3 meters. So let's see here. We can write Newton's laws for each of these guys. And so for this guy, we just have the weight minus the T1 equals the mass times its acceleration. And we know since this cable doesn't change the length, we know that AD is minus AA. So that's the acceleration of this point. And so then we also know that AB with respect to D and AC with respect to D, those are opposites of each other because of this cable, right? But that's just respect to this point here. So that doesn't give us the absolute accelerations of these because this is moving and this cable is, shifting. So then we look at this one here. We get WB. Looks like I just didn't write a minus sign in there. WB minus T2 plus P equals MB times this is the absolute acceleration of V. And let's see here. This doing a analysis of this where this pulley is assumed to be massless, just gives us this, which just tells us that T1 is twice T2. And then this guy here, we get minus T2 plus the weight of this block equals the mass times the absolute acceleration of this block. So then we have, let's see here, we look at kinematics. We know this distance here, basically this here and this here, which is these things, right? That has to be a constant because this cable has a constant length. And so that tells us that AB plus AC minus 2AD is 0. Right? Now, let's see here. And then we can take this, and plug that into there, and we get this expression for our kinematics, relating the acceleration of the absolute acceleration of each block. Now, we know why we know from kinematics that change in displacement of this guy, because it starts from rest, is 1/2 its acceleration times t squared. So AB what did I see? Yeah, so AB winds up being 3/2 meters per second squared, right? Because this was 3 and we have a 2 and then we square this time. So that's what this winds up being. Now we can say A sub A. We can solve this one for A sub A, this equation. And then we can also, let's see here, where did I get this one? 2T2 oh yeah, I just substituted in that T1 equals 2T2, right? That's all I did, and then distributed the minus sign through there. And then we know A sub C, we can get that from here, right? And then we can basically, so now we can plug this into here, this into here. We know AB already. And so now in this equation here, all we don't know is T2. So we can solve for T2 and plug in values, and it comes out to be 51.6 newtons. Now we can figure out what P is, which was another unknown in our in the problem, and we can get that by just using this equation here. And we know all of these values, and that turns out to be just 10 newtons. So we're putting a 10 Newton load onto this to pull it down. And then we can figure out what T1 is, and that's simply twice T2, so that's 103 newtons. So that's the tension in this cable here. And I think that's all they asked for, yeah. So again, just, simple Newton's laws, and then some kinematics, and then just some algebra, basically. And we'll get the answer for that one.